Helium is the second element in the periodic table, and the first and lightest of the noble gases. Helium also has the lowest melting point of all elements, 0.95 kelvins, barely above absolute zero. Yet, helium cannot take solid form. Helium cannot freeze. So why can't helium, unlike all other chemicals, freeze? This has to do with the quantum mechanical concept known as zero-point energy. Zero-point energy is the lowest possible energy that a quantum system may have. Let's take a helium atom. This helium atom contains 2 electrons, 2 protons and 2 neutrons. According to the quantum uncertainty principle, we can't simultaneously know both the position and momentum of said particles. Therefore, even at absolute zero, the particles must jither. Otherwise, if the particle were at perfect standstill, we would know both its position and momentum. This jittering gives off energy, keeping the helium from freezing. It's this energy that is known as zero-point energy. So if the helium doesn't freeze at this point, what does it do? The helium transforms into a very special substance known as a superfluid. A superfluid is a fluid with zero viscosity, therefore it's able to flow without loss of kinetic energy. This bizarre state of matter was first discovered in 1937 by Pyotr Kapitsa in Moscow and has been extensively researched ever since. Due to the zero viscosity, the superfluid helium will creep along surfaces. In fact, superfluid helium can escape from any non-closed container via creeping. Scientists have even produced a frictionless fountain using superfluid helium. But wait a second, wouldn't this apply to the other elements, hydrogen, oxygen, iron, cobalt, bromine, etc. as well? Why do they freeze instead of transforming into a superfluid? Maybe it's because helium is a noble gas? No, because other noble gases like neon can be frozen. The answer is that only helium has a melting point so low, so close to absolute zero, that only helium is prevented from freezing. Other elements like hydrogen and neon, which have after helium the lowest melting points at 14 and 25 kelvins or minus 259 and minus 248 degrees Celsius, have enough range to freeze before turning into a superfluid. To put it more simple, the higher melting points allow these elements to both be solid and jitter. Helium is the only element that can't do both. With a melting point less than 1 degree above absolute zero, even the slightest movement on the quantum level will liquefy the element. Movement such as is demanded by the uncertainty principle will defreeze the helium instantly. It's due to this quantum uncertainty principle that helium cannot freeze. Except it can solidify? But wait a second, GG, isn't freezing the same as solidifying? No. Freezing is defined as turn or be turned into ice or another solid as a result of extreme cold, while solidify is much simpler, defined as make or become hard or solid. There's a way to cheat this and solidify helium at room temperature. But how would one turn helium, or any substance for that matter, into a solid without lowering the temperature below its melting point? The answer is pressure. If one were to increase pressure by 114,000 atms, helium would be solid at room temperature. This is due to the fact that under large pressures the particles can't move fast enough for helium to be a gas or even a liquid. But nevertheless, you could theoretically make solid helium with this. This principle can also be used to make solid oxygen or liquid nitrogen at room temperature, but it won't be actual freezing. And this is why you won't succeed in freezing helium and instead will end up with a supersolid. Supersolids are pretty fascinating, by the way, and I've put all kinds of interesting links in the description below, which you should definitely check out if you found this video interesting. I've also set up a Twitter account where you can follow me and get the quickest updates on my channel and a lot of science that doesn't always make it into a video. I'll see you guys next week.